Welcome everyone, Data and AI Summit 2024, the brave souls that are here for the last day, maybe the last session of the event, right? Thanks for sticking around. Hopefully you don't have to run off too fast to catch flights and we can talk some more afterwards. I did push my flight back pretty far. How about Dipankar?
Yeah, I'm actually flying tomorrow for the same reason.
All right, that's good. Well, we're very excited and thank you all for coming. We think that this is a very exciting topic to talk about this brand new open source project that's called Apache XTable. And we're excited for this new era of interoperability. So we'll start by way of introductions. Myself, my name is Kyle Weller. I am head of product of a new startup company called OneHouse. You can check us out at onehouse.ai. Today we're gonna focus all on open source here and this new project that we created. But you can look up OneHouse. I gave another talk yesterday as well, so you can look up the recording of that once it comes out if you want to get into more details about what our product does and what it offers alongside these technologies as well. But I'll let Dipankar introduce himself as well.
Yeah, my name is Dipankar. I'm part of the DevRel team here at OneHouse, currently focusing on open source projects like Hudi, XTable. In the past, I have worked on Iceberg and also worked on the communities on Apache Arrow. And we're super excited to talk about Apache XTable today. Yeah.
Awesome. Great. Well, to kind of get into the details here, I might step down off this stage, but when you think about data lakes, which of these pops into your head first? Is it the one on the right or the one on the left? I think for me, I've built a few data platforms in my day and built data products to help people build data platforms. Usually I'm a little bit more on this side here with the crying on the floor around data lakes. So why is it that when we go to build data lakes, we get our swimsuits on, we've heard about the Lakehouse, we're ready for a vacation, ready to jump in, and we end up on that side of the slide versus the zen of enjoying the Lakehouse, right? Why is that the case? It is because your data lakes probably look like this, a bunch of random scattered files that are out there on S3 or GCS, ADLS, HDFS, whatever object storage you might have. There's no structure around these files, Parquet files, CSV files, whatever it might be. So I'm pretty sure everyone here in this audience, raise your hand if you have not heard about Delta Lake, Apache Hudi, or Apache Iceberg. Any hands? Any brave hands? I apologize if I'd single you out, but no one raised their hand, so I'm gonna assume everyone kind of knows the basic premise of what these Lakehouse table formats are. And the Lakehouse table formats, they start to add in organization and capabilities that are similar to database-like services. So you've probably heard from these Lakehouse table formats, things around clustering, compaction, cleaning, these other services that work around the files, adding schema and metadata layers to make it so like you're accessing data as if it were from real tables. So data lakehouse is here. This is a fairly new term that's out there. And the way it's composed, you have cloud storage, you've got Parquet files under the hood. And now you've got things like a transaction log and concurrency control. You can have full ACID transactional guarantees on how you're writing updates and deletes into these files. And the Lakehouse, some of the core building blocks, I mentioned transaction, schema enforcement, BI support, so many great things that you've been learning about in this conference and via other venues, I'm sure, as you've been studying and using. Maybe for a show of hands, just so I can get to know the audience here as well, how many of you have built a data lakehouse with Delta, Apache Hudi, Apache Iceberg, one of these three? Okay, well, most folks. That's good to hear. All right, so let me tell you a little bit about the origin stories around these Lakehouse table formats, because I know, especially at this conference here, most folks are familiar with Delta Lake. There's two other projects that are very similar, okay? Apache Hudi, this one was created in 2016 and was open sourced at Uber in 2017. The original creator of this open source project is here in this room as well if you wanted to meet him. He's in the back, somewhere back there. Now, Apache Iceberg was then created over at Netflix in 2018. And what I've put on the right-hand side, these are just screenshots of the first version of the README files. from the first commits inside these projects. Delta Lake, I was actually a product lead with Azure Databricks. I was a Microsoft employee that helped build those first versions of Azure Databricks on Azure. And I was there when we created Delta Lake in 2018. It was a proprietary Databricks feature, and then we open sourced it in 2019. So this is a little bit about the timeline and origin stories here. What I think is interesting is when you start to look at the origin stories, I have a little bit of a personal hot take myself. Because when you dive into the communities, go to the community meetups, look at the roadmaps, read in the PRs and the issues, and talk to people that are contributing and working in these projects, most folks believe that these table formats are on a path towards convergence, that it's just a matter of time until each one has special things that it builds, the other one copies each other, and over time they just become really close to the same. Actually, when you look at these roadmaps and the details, I personally believe that they are building for different purposes and building to different end goals and end states. So something like Delta Lake, it focuses really hard on making Apache Spark one of the best compute engines out there, right? It's also expanded now with the Delta kernel and so many more initiatives. And I think it might also round itself out with the recent acquisition of Tabular and some great movements and things that you guys have been learning about today at the conference as well. Something like Apache Iceberg, it was designed from the very beginning to be a very lightweight, portable specification of how to represent these tables and how to work with these tables. And because it is lightweight and portable, very easy to integrate into a lot of the ecosystem. So it's done very well this way. Something like Apache Hudi, it focuses and has a roadmap that are more focused towards database-like internals. And it has goals to bring some of its unique characteristics. It has a full indexing subsystem, or you're able to set record keys, primary keys, and build out things like record-level indexing. And there's all these database-level services that Apache Hudi is focusing hard to add in that others like Apache Iceberg or Delta Lake maybe don't even want to have inside of their projects. So under the hood, there's lots of details here, and Dipankar has also worked across multiple of these communities. So I want to pass it over to him to talk about some of the technical fundamentals underneath.
Absolutely, thank you so much, Kyle. Yeah, and since most of the room is kind of aware of the Lakehouse table formats, this is going to be an easy one. This is kind of a 10,000 feet view of how the different table formats are organized today. What essentially we are doing here is basically we take the bunch of Parquet files and we do a metadata layer on top of those Parquet files. So in a more technical sense, these are metadata abstractions, and the way they look, the way the metadata is designed today for each of these formats, they may look slightly different, but the overall goal is kind of the same, that whatever we are trying to achieve from this metadata format, the goal is kind of the same. So basically, one of the main attributes, coming from a data lake environment to a data lake house, is that we lack those kind of ACID-based transactional guarantees in a data lake, right? So, you are doing concurrent writes with two writers. How do you make sure two different writers write at the same table, and you have those guarantees, right? Those consistency guarantees and stuff. So that was one of the main goal with having something like that. And of course, there are other things like, performance optimizations that kind of gives you benefit in terms of query pruning and those kind of things. So these metadata files allows you to track those statistical information about the Parquet files, the underlying data files. And it allows you to apply different techniques like I said about for example, you can get the minimum and maximum value, column value from this individual columns. And instead of reading and your query engine reading each and every Parquet file, it can just go to this metadata layer and just see which Parquet files can have those records that your query needs to be satisfied for. So that's what basically the kind of a 10,000 foot view, what the table format looks like. All right, so how it looks on the cloud storage, right? So all of these table formats, like I said, they have quite some similarities. And fundamentally, they are kind of not that different. So when data is written to a distributed file system or a cloud storage like this, you can exactly see what's happening. I'm hoping it's visible to the audience later as well. But if you see, let's say a Hudi table, right? Hudi has a metadata timeline. Similarly, Delta has its own transaction log. It's again a timeline-based approach. And Iceberg has a different way of organizing things. They have the metadata file, the manifest list, the manifest file, and of course, you see the Parquet file. So kind of the common denominator in this three table like abstracted format is that you see the Parquet files that's kind of similar in each of them. It's just the way the metadata is designed, and that's what I was kind of like leading towards like this particular thing. So that's what you see here, and the differences are kind of visible in a way. It's only the design difference that's kind of like makes them in a way different. So that brings us to kind of the like million-dollar question, right? What format should we choose? I personally have been in like, I have worked in like the Iceberg community in the past. Now I also focus on Hudi, and my experience has also been with Delta in the past as a data engineer. So it's kind of a tough decision, right? I mean, like each of the formats have their own unique specifications. Like Hudi can be really good with like mutable data, faster ingestion. Iceberg can be good on the read side. Delta works really good with the like overall Databricks ecosystem and Spark. So I think instead of like going through like the comparison articles and like a bunch of comparison features, what I'm going to like focus on now is that what if we could use all of these three table formats, right? And usually the response to this is either it's like shrieks of joy, like, or people who have never thought about it, they're like, why do we even need three different table formats, right? So that's kind of like what we are leading towards. So we put together a few examples, and again, this is far from comprehensive, but this is just a way to show how we can like work towards different ecosystem and have that flexibility to choose a particular table format. And if needed be, you have the option to like, switch between the formats and make it more interoperable versus migration, which is like a super cumbersome thing to do. So you could use like, for example, like maybe you choose Hudi, for writing with EMR and Spark. It really gives you like faster writes with mutable workloads, and also a lot of parameters to tune for ingestion, purpose. But on the Delta side, maybe on the Databricks side, maybe you want to use Photon, right? It's a C++ vectorized query engine. It works really good with like Delta Lake. And so maybe you want to use that on the other side. Similarly, you might be using Delta Lake with Fabric on the Microsoft ecosystem. And then you might be using Snowflake on the other side, which currently only supports Iceberg. So, that's something that you want to like interoperate between. So having said that, I'm super excited to introduce this brand new open source project that just started incubating under the Apache Software Foundation Foundation. So XTable allows you to do omnidirectional translation. And the reason I say omnidirectional is because it allows you to like start with one format, and you can just round robin and start from like Hudi to Delta, Delta to Hudi and back, and you can just go in any fashion. So it's also important to note, like, we are not creating a new format here. It's not a new, like a separate format or new table format at all. XTable basically offers abstraction. It's an abstraction layer, set of tools that allows you to basically switch and interoperate between the formats. So this way of interoperability is, like I said, it's kind of like versus one of migration. It kind of takes you from another route where you're like, spending a lot of efforts in migrating from one format to another, and the decision to, at the first place, to like select a format is itself a challenging one. So this is what like XTable aims to solve, and the overall goal with XTable is that you can start with any format today, right? You can go with any format that is available, but if need be, and if your requirements can change over the years, maybe your ecosystem changes, your data strategy changes, you're free to like just move around and like use something else. So that doesn't have to be a cumbersome process overall. So that brings us to how we started XTable and how we kind of like ended up here. And I think Kyle has a better idea of like how we have reached this point. Yeah.
I was there since the beginning of the project, and also on this last screenshot, the screenshot's a little outdated. We're almost at 800 stars, so if you want to slam another little star in there, all of those help to spread awareness about what these good projects can give and offer to the community. So we definitely appreciate that. So to give you a little timeline of how XTable got together, in February of 2023, we announced that we were going to build Apache XTable, and at that time we called it OneTable. So if you've seen any buzz or things online that reference the name OneTable, that was its previous name. Then we co-launched this as an open source project alongside with Microsoft and Google. Then earlier this year, we completed the donation of of OneTable into the incubation program at the Apache Software Foundation. And at that time, we renamed the project to Apache XTable. Now on board inside the initial PMC and mentors and users and collaborators there, we have also folks like Cloudera, Walmart, Dremio, Adobe, alongside where the original 3 were in line with that project. And folks likely know what some of these open source projects is, but some folks aren't aware of the governance structures and things that the Apache Software Foundation adds to the mix. So it's one thing to open up an open source repo, but when you donate it to something like the Apache Software Foundation, you also give away all of the rights and ownership. No one in this mix has admin access to the GitHub repo. The Apache Software Foundation owns this, and so no one vendor can control it. And we had goals that were specifically around this, right? We're trying to bridge the gap across Delta Lake, Iceberg, Hudi. You've probably seen lots of content online about folks that say one is way better than the other is way better than the other, and people having some kind of flame wars online, right? To build a position where multiple diverse communities can come together and actually collaborate, it needs to have proper governance and also be in a really vendor-neutral location. So this was a core part of creating XTable as well. Now, really excited, even just as of last month, some really exciting announcements of more people coming on board to the Apache XTable project. There was a great announcement at Microsoft Build Conference 3-4 weeks ago or so. There's some Microsoft friends up here in the front, where Snowflake and Fabric, they use Apache XTable under the hood to translate across Iceberg and Delta Lake tables inside of one lake. And then even folks like Databricks are collaborating with us actively in the Apache XTable project. It's likely that folks here have also heard of Delta Lake Uniform, because Uniform has a lot of discussion in the keynotes and other sessions here from Databricks as well. And so to help on that front, we actively meet the engineering teams that are building both projects. We actively meet often, and we're sharing code and collaborating. It's maybe unfortunate that there's 2 distinct projects. They both have the same goals, but I would encourage you to check out either of these projects as it goes. So I will pass it back to Dipankar to get even deeper into some more of the internals as well.
Right, so I'm gonna go more on the technical side and speak a bit about how, and we're going to see a demo later, of course, Kyle is gonna show that. But in general, how it works, it can get as simple as this. So you choose your source format. It's a YAML file, and you can define your target format. So you start with Hudi, or let's say Delta, and you define your target as Iceberg or Hudi, whatever, and XTable will do the translation on top of that. So all you basically have to do is select your source and target, and then it's basically a jar file right now, which you can execute through various ways. There are different ways to do that. You could trigger after a Spark DML, you can ask the Spark writer to write the metadata itself. Or it can be an Airflow job, right? Or some kind of a Lambda function as well. So there are different ways to productionize this and different ways to work around on this particular thing and how you can run it. But standalone, at its basic kind of primal form, you can define your source, you define your target, and you run your jar file, and that gets you the metadata on the same bucket, on your same data lake, whether it's S3-based data lake or Azure, or whatever it is. So the most important thing to note here is that and we kind of keep on reiterating that part, is that we don't touch the data part at all. We are not rewriting the Parquet files here at all. It's just a metadata translation, and that's why it's so lightweight. More on the XTable's architecture. So just to give an idea of how internally things look, right? So we have 3 main components here, the convergence source, the convergent target, and the core logic itself. So starting with the convergence source, these are table format specific modules. And they're responsible for reading your source metadata, the metadata from your source table. If you, let's say, define your source as Hudi, it'll basically read your Hudi metadata. And they operate using a kind of a pluggable file system, so that allows you to be able to connect through different data lake implementations. And the whole idea is that it will extract information around the schema, transactional information, partition-related information, statistical information. Those are the information that are kind of aggregated here, and that's what the convergence source part does it. The next part is the core central processing unit of the XTable, which is the conversion logic. So this part is responsible for the entire translation process. It orchestrates the entire process, responsible for initializations of the various source, the various target, cache management, state management, and all those kind of incremental processing way. Because how we can run XTable is also in an incremental fashion, so you don't have to every time do a full load. XTable can basically understand from what point it didn't sync the data, and from that point, you can just incrementally load the data. So it kind of really helps with larger tables as well. And the final part is basically the conversion target, which basically is like a mirror of the source reader. So all it is doing is so in the core logic part, we are making unified representation of what we kind of gathered from the source part. And that's what it's writing back in the target part. So this includes like recreating the schema, transaction logs, and all this partition details and statistical information in the new format, in the new metadata format. All right, so maybe Kyle, you can add some more context around like the interoperability aspects.
Yeah, and some of the motivations for originally creating the project, because some people ask, hey, why create it? What were some of the goals behind it? Now, these are some statistics from a research firm that's out there that shows that somewhere between 40–50% of users that use Databricks also use Snowflake, and vice versa. So there's quite a large amount of overlap of users on both areas. Historically, things are changing, of course, you see this week during the conference, but Databricks historically has been mostly through and through Delta Lake, whereas Snowflake decided to just pick support for one format also, just with Iceberg. And so from our perspective of OneHouse, we're actually building a platform to try to decouple all query engines from how you build lakehouses and the foundation of your lakehouse, and do rapid streaming ingestion from various sources like databases or event streams or even cloud storage. We write these into Apache Hudi tables, Delta Lake tables, Apache Iceberg tables, do advanced optimizations and even low-code ETL pipelines and synchronize these to all the catalogs. Now, because we're trying to build what our tagline of like a universal data lakehouse, we had lots of folks that were in those overlapping concentric circles. And they said, well, I use Databricks and Snowflake, can you help me out? And we heard this overwhelmingly from our customer base, and so we decided, that's why we originally decided to use one table itself. I'm curious, even from the audience here, let me switch this. If I turn this back on, even from the audience here, I'm really curious to hear your take on which query engines you are using as well. Let me go there and put this in presentation mode. Okay, what you can do, there's a QR code right there. You can scan that, and it's very lightweight, just on your phone, and it doesn't get any your name or anything like that. It's just anonymous, whatever. You can scan that. Hopefully the captions don't block you. If anyone gives me a thumbs up that it's working. Okay, I'll be quiet for a second. Let's see if the captions go away. All right, we might have to skip it then. Actually, I got one idea. If I lift this up. All right, now? All right, I'm seeing thumbs. Okay, try it out. I'm curious, just from this room, which query engines are you using? You see it's updating live here. It's always fun just to get the vibe from folks that are at these conferences while we're all networking together and see what kind of diversity is out there. If I were a betting man, Dipankar, what do you think? If I were a betting man, I'd be putting my chips on Spark because this is the Data and AI conference right here.
For sure, yeah.
But,
Spark takes a major share for sure, yeah.
All right, and we're getting lots of Databricks, but you see, look, 15% Databricks, 13% Snowflake. Those are some concentric circles building right there. Oh, it looks like we got folks on EMR, Athena, Fabric. All right, Fabric, my folks up front here, I know you pushed that button. And some Flink users. Where's my Flink users at? Yeah, Flink. All right, nice. You're doing some real streaming workloads there. That's good. Cool. It's just fun to see this diversity. Thanks for adding this in the mix. It's fun to connect on these details. After this, that's some of the motivation, right? You see it right here, firsthand. Diversity of query engines. We're trying to, as our product, our OneHouse company, trying to decouple these query engines from how you do your core storage, and this is evidence right here of why we're doing this. So now we actually wanted to move into a demo. So enough with the slides. You guys want to see it run live. I'll make mention just because it's right here. You can bookmark this if you go to xtable.apache.org. It has all the documentation, quick starts, GitHub repo links, all those kind of things. Here is GitHub as well. So all of that is available for you to use and enjoy after this session as well. Let me flip over to my demo notebook here.
We know how demo works, so hopefully we'll be able to execute what we expected for.
Let me make sure, because I saw that little, all right, everything's online. Okay, so what I've got set up on this demo, this is a Jupyter notebook. in the AWS environment backed by an EMR cluster, okay? The same thing works on Databricks. Hopefully no one boos me off the stage because I'm using EMR instead of Databricks or something, right? But it's all Spark, right? And so what I'm going to do, I have some data in S3. Let me come back here. I've just got, it's a really simple demo, okay? Just like one Parquet file, just some random data. And what I do is first read this data. I say spark.read.format Parquet. I load it in. You can see this is some kind of table of sample data. The first action I'm going to take is write this Parquet file out as an Apache Hudi table on S3. And the way you do this, you just say spark.write.format Hudi. You've loaded up the libraries. You also can use Hudi and Iceberg both on Databricks also. Both of that is possible. And now I've written that into S3. So if I were to come back here, you will see this table has my Hudi table. And like Dipankar described to you, there's the Parquet file, right? This is a simple demo, one Parquet file. You can imagine though, you might have terabytes, petabytes of like a whole table, partition table. Now Hudi has this .hudi metadata folder. This is the timeline and how Hudi works with this metadata. Now I'll come back to my notebook and let's just make sure this still reads back as a Hudi table, just for the proof that way, read.format Hudi. Let's try to read this with read.format Iceberg. Of course, it fails. This is not an Iceberg table. This is a Hudi table, right? So what we do with Apache XTable, when you go to the website, you check out the docs. These details are in the quick start. The first thing you do is create a config YAML file. I think you described this as well, Dipankar, yes? So in my case, I chose for some reason that I wanted to use Apache Hudi first. So I say Hudi is my source format, and Delta and Iceberg are gonna be my target formats, okay? I give it the path that I have, and now all I have to do is run a really simple jar utility here. So let me grab this, I'll copy paste this even, and I'll switch over to my command prompt here, and I'll just pump this in, and it's going to run in the background like Dipankar described. This is a lightweight operation that does not even read the Parquet files themselves. It looks at the Hudi timeline, or it would look at the Delta Lake transaction log, Iceberg manifest file, and will create the other versions that you wanted. So you see I refreshed this, and I've got the folder for the Delta log, and you see this is the Delta Lake transaction log, if you guys are familiar with using it that way. If I go back, you see this metadata folder right here. This is the Iceberg manifest file in Avro right here, okay? So on top of the same Parquet file, this Parquet file did not change. If we looked at the timestamps, it wasn't even touched. We just swapped the metadata and represented, they're all in the same folder path. So now I can come back to my notebook and say, spark.read.format from that same path, I can read it as an Iceberg table, or I can read it as a Delta Lake table. And so all three legs are complete, and I have truly achieved interoperability and let our powers combine, right? So I had another demo type where I was going to create a snowflake table, write it out as Iceberg, convert to Delta, read in Databricks. But this morning, I'm sure all of you loved some of the keynotes this morning, especially one that I enjoyed was Mate up there talking about Unity Catalog. And you saw how he walked over to his laptop and pushed that GitHub repo live just this morning. So this morning, I actually wasn't feeling too well this morning, so I was in my hotel room. I decided to try it out. I decided to play with it. And now we've got a Unity Catalog demo linked up in this. So I just made it a few hours ago. Let's see if it works. But if I come over to the documentation, I think I have it here for Unity Catalog. They mentioned the website, unitycatalog.io, and you can get to the GitHub repo. And so I just cloned the repo. And the first thing you do inside of their quick start is you start the Unity Catalog server. So let me go back to my terminals, and let's do this. Start the Unity Catalog server. I already installed everything and set it up behind the scenes. But now I have a Unity Catalog open source server running over here on this terminal. I'll flip to the other side. And you know, I've been playing with this for just a few hours, so I don't know all the ins and outs, right? But you can read through the documentation inside these quick starts, and you can start to learn it yourself as well. It comes preloaded with a couple sample tables, couple demo tables. So you can run things like, if I come back to my terminal here, maybe I need to increase the text size as well. So I can say, show me, list some of these tables, so it has some things preloaded inside there. Now, the table that I created in S3, right? This table is all three formats. This table is Hudi, Iceberg, and Delta, right? Unity catalog, I'm sure it's gonna, even on the website itself, it shows that this is going to be multi-format compatible, right? So I don't know if it is in its first version, but it will be, and we're actively collaborating with the folks over at Databricks to help make this happen in the community. But now I can come and register this table. Let me grab my create table statement. I think I have it just in here. My create table statement for Unity catalog. It's a little bit of a mess here. Some of the commands you're entering are things about, hey, the format's Delta Lake, the storage location is my path in S3, and then I specify what the schema of this table is. So I can create that table in Unity catalog, and you'll see that it's now registered here. So it says, this is my table, and you probably saw all the amazing demos of Unity Catalog earlier, the capabilities that it might offer. So one of those is, if I switch to, I think this one, inside the quick start here, it also suggests, where's that window? I got so many windows. This one. It also suggests that you can connect this to DuckDB. So where is it? Here, all right. So I will start in this terminal. I'll start my DuckDB client. And the first step you do with this is load up the libraries here. So I will add these to my DuckDB client here. You create a token. I will create this here. Then you attach the Unity catalog. So I will add this here. And now if I say show all tables, so if you're familiar, raise your hand if you've been using DuckDB or tried out DuckDB. A couple folks. So this is all just local on my machine right here in memory, right? But now I will have my table registered, this one right here, my table demo XTable. You can see there's some Hudi metadata associated with it, but it is a Delta Lake table in S3 that I can query via DuckDB on my laptop and have the governance in place from Unity Catalog also. So pretty cool that we can announce and deliver an open source project in the morning and then maybe get it loaded on the side into the live demo here today. So I'm excited to try this out and learn more about it as we go. Let me flip back to the slides. This one. All right. Okay, we went through the demo here, and Dipankar, if you want to talk us through the vision, some of the next steps and details.
Absolutely, yeah. It's really like amazing to see how the community is working towards kind of an open data foundation here. Thanks so much for the demo, Kyle. Yeah. So where are we going with the project goals and community in general, right? Obviously, we are focused on community because we are donating to Apache. We have donated. It's incubating there. So obviously the goals in terms of the project is like we want to eliminate data silos, of course. We have seen with our experience how different teams have different data sets, like one on Iceberg, one on Delta, and that's the whole idea with XTable. So of course, we donated this to ASF, and the idea is to have robust governance and all those policies like project needs. We have been using Apache projects for long, so we understand that very well. It's neutral, most importantly, vendor neutral. So we have committers. We invited committers and mentors from all these different projects like Iceberg, Hudi, and Delta Lake to contribute to the project, and it's really great to see the open source community come together for this. Also, it will be really interesting to get some feedback from the data engineering community. If you try it out and you want to get involved, we have our GitHub page. Get involved in the discussions. If there is an issue we find, we should be able to sort it out together. So yeah, that's really a good idea. I also wanted to pull up and give it a shout out. We don't have much time, but yeah, we have some initial committers here. Also some from different angles and perspective. For example, we have users now, we have mentors now, we have contributors already there. So folks from one house, this is where my organization contributes. Microsoft, Google, Dremio, Adobe Cloudera, and all those names. So in terms of the roadmap, right? So we are at the kind of the beginning phase of the project. Obviously, like there's been a really good momentum in general, and of course the interest from the community has been really good. And we want to keep building on it, right? And we want to think about the next phase of the project as we kind of keep building. So here's some of the quick things. Obviously, like we started with like testing these different formats, testing different query engines like with these different formats. And then we and I are talking about like different like features, feature parity is a super important aspect here. Deletion vector is I think actively on talks like how you get into different formats and make it interoperable. Performance improvement, that is one area. Right now, when we read the source table metadata, we load it in memory and keep it for some time. Of course, the overhead is really less, but we want to make sure we hit these really large tables and we are not loaded in some way. We also want to be able to handle more loads, right, without compromising on performance, and also keep like cost of goods under control in that way. So here are some handy links I thought could be useful, like GitHub, Kyle talked about the documentation, and we are also pretty much active on our socials. So LinkedIn, Twitter for all the new updates and what's happening in the community in general. And so if you're interested to contributing to the project in any form, like whether it's documentation, whether it's like testing out things, bringing new query engine features, I think this would be like a really good like community to come together and talk about it.
And the Apache Software Foundation, a lot of these projects run on these mailing lists as well. So join that, send an empty email to that email address right there, and you'll be on the mailing list. You can jump into any discussions and collaborate with the community too.
I think we also started doing the community call, at least one of them, yeah. So that would be a good one, like to just join and just understand what's going on with the project in general. But that's pretty much our time. Thank you so much, yeah.